Yeah, thank you, Sergio. Good afternoon, all. Good morning for those in the Pacific time zone. Yeah, this is a very interesting and fascinating project, as Sergio mentioned, and where from the Exceed side, multiple different specializations like of ECSS. We're happy to help here. It's certainly a novel and innovative in the sense that typical ECSS project we see come requesting help for lots of performance improvements and so on, or code portability. Here, this is a category where they need a lot of productivity and increasing, and it has a lot of machine learning components. But more importantly, one of the early projects we were trying to help them with a lot of data-driven decision-making projects. So we will learn more about the project, but I'll just briefly say that we have 4 speakers today. The Meghna, the PI, had a conflict, so she couldn't make it, but shared us with a video recording. The co-principal investigator on the project, Dr. Samuel Rivera, is here. Thanks, Sammy, for making it. And he'll start, he will, after Meghna introduces the project, he will elaborate it a little more. And then we'll have 2 Exceed staff members, Eroma, Abeysinghe, and Eric Coulter from IU. We'll talk about the Exceed portions of the help here. And so given we have 4 speakers here, so feel free to have the questions coming up, like on the chat. We will try to answer them. Those of us who are not speaking will try to answer them on the chat. And we'll also have breaks in between and towards the end to take time for the Q&A. Again, thank you all. Let me get started here.
Today, we are going to give you a little overview presentation of what the InterACTWEL Cyberinfrastructure is all about, how we developed it, and what is the vision that we have, as well as what kinds of workflows the cyberinfrastructure supports. The main motivation behind creating the cyberinfrastructure was to really...
Oh, sorry, you cannot hear the audio, Sam?
I hear the audio, but not video. Is it only audio?
Oh, no, the video will keep coming in. So you'll see the slide and with the Meghna's picture, right? So they'll keep moving as she talks.
Oh, okay.
Yeah, thanks, Sergio. Yeah.
Provide mechanisms and platforms and technologies for not just researchers, but also communities who live in the landscape and in the watersheds all across the country and all across the world to be better prepared in identifying what kinds of management scenarios and water, energy, land management strategies might help their natural resources be better prepared, as well as their own economic sectors be well prepared for managing climate change stresses and shocks. For example, things like droughts and wildfires and floods in the future. So providing those capabilities that these communities can use over a long period of time, as well as capabilities that leverage artificial intelligence and other data analytics approaches was a key central element of that supports the motivation behind this cyber infrastructure. So for today's talk, I will give you an overview of the InterACTWEL vision as well as our approach, the overall approach. Then my colleague Sammy will talk about the different data sets and data parsers, as well as different computations that are involved in the cyber infrastructure, as well as discussion about the different user experiences and what kind of approaches we are taking to provide experiences for our end users to the different interfaces that are being developed. And then finally, our colleagues at the CERC Center will talk about how the gateway has been developed in partnership among all of us, as well as the integration plan. And then we'll close the presentation today with some thoughts on the future work and the scope of where we go from here. So InterACTWEL actually stands for Interactive Adaptation and Collaboration Tool for Managing Water, Energy, and Land Resources. And essentially, this tool is being designed to serve as a decision support platform for local communities. So you're not thinking about national scale or global scale. You're really thinking about river basin scales or watershed scales, where multiple agricultural communities or even urban communities can work together to better manage the resources that their watersheds provide them, so that they are better, better prepared for the kinds of climate-induced stresses that the community might face over the long period of time. So it's really supposed to be providing long-term services. And so that's one unique element of this cyber infrastructure. The other unique element of this tool and the cyber infrastructure that supports this tool is the type of end users that we envision for the InterACTWEL CI. So, like I said, from a layperson's perspective or a common end user's perspective, InterACTWEL serves as a web-based decision support for adaptation scenario planning. But to create the decision support capabilities, it also serves as a science gateway where researchers can bring in their state-of-the-art models and data and analytical capabilities, integrate them into the science gateway for their communities that they're working on or partnering with. And then the end users can use those capabilities to be able to visualize plans and develop scenarios for managing different kinds of stresses in their region. So overall, InterACTWEL is really aimed to empower communities in watersheds. And what I mean by communities, the definition of communities here is not just the researchers who will be using InterACTWEL and further advancing InterACTWEL capabilities, but also managers and agencies like land managers, water resources managers, or even municipalities who need to work together to create those scenarios of adaptation strategies for their watersheds, as well as the inhabitants of the watersheds, like farmers or individual urban dwellers or people who live in the watershed. They also are impacted by the decisions that are being created to manage the stresses in their landscape. So engaging them and being able to make sure that whatever data analytics are done and communicated are also communicated to the end users, who are an important part of creating adaptation strategies that improve their entire community's resilience to these stresses. So how does InterACTWEL help empower these communities? It basically provides them platform and a decision support platform to be able to coordinate the different adaptation strategies related to their own sectors, but strategies that can help them better respond to the different stresses and changes, whether it's long-term droughts or recurring floods, for example. How do you manage these stresses and better manage by better management of your water, energy, and land resources? And so, since in the management of these natural resources, the agencies and groups that have been created across the country are siloed and they manage their own decisions very independently, creating a platform that allows them to interact and coordinate and collaborate provides really useful and powerful opportunities to bring in state-of-the-art data, state-of-the-art models, state-of-the-art visualization capabilities that the different groups can then bring into this platform that they would otherwise use it for their own decision making, but then allow their own capabilities to be networked and connected with other groups' capabilities for data analysis, so that you can really develop a much more comprehensive community plan and community scale data analysis and information. So like I said, how are we doing this? We are basically providing data-driven services for these planners and managers to be able to simulate, visualize, evaluate, as well as share scenarios of these multiple sectoral adaptation actions that they might be interested in adopting, whether it's how do you manage, say, a river, how do you manage dams, how do you manage farms, or how do you manage energy generation, where you are using these shared land and energy and natural and other water natural resources. So how do you develop scenarios of adaptively managing those shared resources over time that can reduce their larger watershed communities' vulnerability to these climate-induced stresses? So the overall vision is to really, of the InterACTWEL, is to help efforts and projects where you do in-person stakeholder engagement with your community and decision makers, and you facilitate and you learn from them, and you co-produce information and knowledge so that you can better understand who are the different decision makers in a community, how do they manage their current natural resources, and then use that kind of interaction with the end user communities to then create a conceptual model of how the different socioeconomic systems in a community or different sectors in a community might be interested in exploring different types of adaptation actions, and what kinds of impacts do they foresee those actions may have on their natural resources, as well as on other groups in their watersheds or other actors in their watershed. Now, once you develop the conceptual model, that conceptual model then becomes like the baseline model for driving what kinds of data are brought into the InterACTWEL platform, as well as what kind of models are used to simulate different scenarios of adaptation actions, and then what kinds of data is visualized in the graphical user interfaces of InterACTWEL, and in what manner are these scenarios compared with each other so folks can learn, end users can learn about which actions work better than the others, as well as provide feedback through the InterACTWEL platform user interfaces to your back to your researchers and managers and agency folks about what actions may work better than the other and what strategies should be changed in what manner. So it's really trying to create a better, tighter platform for developing scenarios, as well as receiving feedback from your end users about the scenarios. So the scenarios can be developed in a way where management strategies are more acceptable to the community and are more likely to be adopted. So the InterACTWEL's workflows have these 5 stages for supporting the stakeholder-driven adaptation planning process. Like I said, in stage 1, you work in person or through capabilities, whatever facilitation capabilities you might have, to co-produce knowledge about what does the conceptual systems diagram of your community looks like. And that conceptual system diagram drives in the InterACTWEL environment how the different community projects are set up, what kinds of data and simulation models are run, what kinds of optimization techniques are run to generate these scenarios, and then what kinds of data is visualized in stage 4 about different adaptation plans the community wants to explore, as well as what kind of feedback you want to collect from your community to better understand which adaptation plans might be more reasonable for the community's perspective. So we have built the InterACTWEL website that's like the entry point for the different types of end users. Essentially end users can create their own account and have different kinds of privileges and access capabilities to different kinds of services. The back end of the cyber infrastructure, which my colleague will shortly talk about more in detail, is essentially allows different types of end users. We sort of classify them into administrator type end users, who are the technical experts in the different areas or the different sectors of the community and bring in the data and models that are relevant to their sector into the InterACTWEL platform. And then there is another kind of users called the actor users, which are really the group of users who may be technical, but may also be non-technical, but are really interested in visualizing the output of the simulations and the scenarios that are created in the InterACTWEL platform, so that they can visualize different strategies, different scenarios, as well as provide feedback on which scenarios are more likely to be adopted or not. And then to create that kind of interaction with these end users, we have created a dashboard that allows them to, once they enter their account through the web login, they're able to either learn about the InterACTWEL platform or prepare or create these different scenarios, and then share the scenarios and sort of act on what decisions might be more likely to be adopted. So this is still work in progress, but there are multiple elements of this dashboard that have been developed over the last few years. And then once plans are generated, say for a community, for example, in this picture, I'm showing you a screenshot of the community in the Umatilla River Basin in Oregon, where we have been using the community as a test bed for our cyber infrastructure. basically it allows, these interfaces allow end users to then use geovisualization capabilities in InterACTWEL to compare data of different, whether it's spatial data or whether it is just different kinds of disclassification data, to be able to compare different aspects of different actions that are being proposed, as well as what the impact they might have on the community's goals. And then based on, when they compare different scenarios, then they can evaluate those adaptation plans that are being proposed by the tool and provide feedback as to which plans are, are good plans or poor plans, or which ones they are more likely to adopt, and so on. And then for each plan, they can also look at things like what kind of actions are being proposed over time. So there's capabilities and visualizations about examining different long-term actions that they might have to adopt and change over time in order to be resilient to the stress that the community is planning for. So for example, in this region, we are planning for long-term droughts. So with long-term droughts, as climate changes, what kinds of changes in water management and land management strategies would this community have to make in order to be resilient to those drought stresses? So with that, I'll stop here and let my colleague, Sammy, talk about the different data and data parsers, as well as computations that are involved in this InterACTWEL platform. And thank you so much for the opportunity.
Sammy, please take it away.
All right, let me see if you can see my screen. Is that good?
Yep, we can.
All right, perfect, awesome. All right, so hopefully everyone was able to hear and follow Meghna's kind of big picture introduction and overview of the project. What I'm going to be talking about in the next 10 to 15 minutes, it's essentially a little bit more in details about what makes the data, the models, and the computational needs of this project unique, and why we really depend on the cyber infrastructure to be able to explore some of these research questions. And so I'm going to be presenting this discussion from a very user-centric approach, in which I'm going to try to convey the experience that we're trying to provide to the users, the different types of users, as they go through the user or the web interface. And so in order to do that, then we need to basically define what we envision to be the end users of InterACTWEL. And we mainly categorize it in three categories. The big overarching category, it's the global, what we call the global administrators. And so these global administrators are, if you want to think about it in this way, they're the PIs of the project, right? They have complete control of the project. They're the ones that go into the Science Gateway, propose a project, decide on what region is going to be studied. They're the ones that have the money to support the project and the modeling efforts and everything else, right? So they have complete control of the project, meaning they get to accept or invite people into the project. They assign different roles to different people. They have complete control over the data, the models, and the the applications or the simulations, as we call them. And so they're really just, they have control of the whole project. A little bit lower than them, it's what we're calling the local administrators. And so the local administrators are really your sector technical leaders or managers, right? So these are the people that you're going to be relying on to provide data, perhaps models as well. What are the decisions that are being made in different sectors, in the food, energy, or water sectors in that region? What are the constraints? What are the decisions that they're considering? What are the goals that they're thinking about as far as like adaptation planning in the future? And so really they're the ones providing a lot of the information that goes into the formulation of looking at this adaptation plan. And so one big thing about local administrators is that because of a lot of the sensitivity of some of the sectors, for example, you can imagine, for example, the energy sector, if we have energy utilities or water utilities, some of that information is sensitive. A big aspect of the local administrators is that we right off the bat say they need to have complete control over their data. They need to have control over who can see their data, who can they share their data with, and how can their data be used. And so the global administrators is someone that hopefully the local administrators trust. And so they will tell the global administrators, hey, this data, it's only for you, or it's open to the public, and so forth and so forth. And then the last part about the local administrators is that once the global administrators set up different projects and different simulations, they can go in and tweak different parameters in the models. And so they can run different scenarios based on what they're thinking about, different decisions and things like that, without necessarily bothering the global administrators for running some of that stuff. And then the last part, or the last group of users, is the actor users. And this is basically the whole community. Whoever gets impacted by whatever problem it's being researched gets included in this group. And so that can be a resident of the watershed. It can be an actor in one of these sectors. So for example, in our case study project, we are dealing with a lot of farmers, right? So the farmers themselves won't have direct access to some of the data or some of the modeling efforts, but they will be able to essentially visualize and evaluate different adaptation plans that are being presented to them. And so it's really just the general public, whoever it's interested in the project. And that includes researchers as well, right? If we want to include researchers to come and see different aspects of the project, or perhaps they can want to contribute in a different way, they are included in this category. Okay, and so the reason why I went into a little bit of details about the different actors is because, or users, is because, as you can start imagining, right, this data proprietary and data sensitivity plays a big role in how we make decisions about the science gateway. And so once we start looking at, okay, we have these three groups and we want these groups to have essentially the same experience through the graphical user interface, right, through the science gateway interface. And so we want them to have a flexible, seamless experience through it, kind of intuitive interface. How can we make that happen in a way that we still maintain some of these, hierarchical levels of security? And so this is kind of an overview of the technological components that it's included in our science gateway. The back end of the whole science gateway, it's supported by Apache Air Avatar, and probably Suresh and Eroma can speak in more details about some of the intricacies related to this project. But once you have that, then you basically need to store your data, right? And we have basically three kind of buckets of data where we store different types of data. We have our JSON MongoDB database, where we essentially store everything that it's an input or a result of the simulations, but that gets displayed through the graphical user interface. And so anything that will be presented to the users, whether it's in the form of an input to the models or a result of the models, it gets stored in that database. We have our experiments metadata. So essentially, who gets to submit what models, what input data was used, what was the output data, what computational resources was used. And then that way we can keep track of, who's submitting what and whether they're doing it correctly or not. And then the last part is the part that I wanted to talk a little bit more in detail, which is the database for the case study formulations and model data. And so this particular bucket, it's pretty important because this is where we start making distinctions as to who has access to what. And it's kind of interesting because the models need access to all the data they can get, right? The more data that you can have for the models to represent your region and what's happening more accurately, the better, right? And so that means that the models don't differentiate between who's supporting or who's inputting data. But as far as like accessibility to the data, because of that sensitivity that we were talking before, then we needed to make some distinctions. And so here to the right of the screen, I'm presenting kind of this general case study, if you want to call it, of having global administrators having access to basically everything, what we call the global data bucket. And then each of the local administrators are presented as a group. Okay, and so each of the groups has a little bucket which represents the data inputted by each of those groups, right? But then within each of those group buckets, you have individual buckets contributed by different people. And so in here, I just provided two examples, right? Let's say, for example, that you have a farmer that only wants to share their data with the global administrator because they are concerned that if their, recipe for fertilizer application, tillage, some of the land management operations gets out, and because other farmers are in that same bucket, they might, look at that data and then become a threat for competition in that sense for them, right? So they might just want to share it with just the global administrators and say, hey, I know you need this data for running the model, but don't share it with anyone because I'm afraid of the economic consequences, right? You can have people like, for example, the energy utilities that might say, hey, I have, all the power line locations and, I'm okay with sharing that because that's public information. Let's share it with everyone so everyone has access to it. And then usually the default is that the data is only shareable within the groups and obviously with the global administrator, right? And so this was the first challenge that I think the Science Gateway community had to tackle for us. And I appreciate Suresh and Eroma and everyone involved taking a crack at it, because it really was a unique aspect of this project that kind of threw us for a loop there for a bit. And so now we have all this data, now we have all this, data privacy issues fixed. What do we do with it, right? At the end of the day, we don't want to be sort of just a storage for presentation of data. We want to provide simulation and analytical capabilities, right? And so once we have all this data and the global administrators have set up correctly the models, we go into this simulation optimization framework. And this was the second challenge that we faced, that we made this project a little bit unique, right? Depending on the region, you can start imagining everyone's going to have a different problem. They're going to have different perturbations they want to research. They're going to have different issues in that region they want to explore. And so the models they might use are going to be always changing, always evolving, and they might always be different, right? And so we had to be mindful of that and create something that was flexible enough to be almost like this, what we're calling the plug and play modeling platform, in which you can, once you create this applications, as they're calling the Science Gateway, you can then pick and choose which ones you want to use, right? And so for our particular case study, we're using 3 different models. It's the SWAT model, that's for the land and water management and everything included in that. We have an energy model that it's very specific to the Pacific Northwest. And then we have an economic model that looks at the impacts in the region that was developed here at the at Oregon State University. And so it's very specific to that region. It will be hard to take that economic model and then apply it directly into another region, but it's there for other people to use it to get inspiration from, perhaps tweak it and then apply it to their regions. And so once you have these models, then the part about evaluating different adaptation plans comes into play, right? And so for this, what we decided to go with, it's with a decentralized multidisciplinary design optimization framework. And I know that's a mouthful, but all that it means is that it's a framework that allows you to optimize different systems, giving a set of global objectives and then also individual objectives at the same time. And so it allows you to look at models of different spatial and temporal resolutions. It allows you to look at perhaps different global and individual optimization objectives. But at the end of it, it's trying to find whatever it's the best consensus from all of that. And so that's one of the biggest things that we're going to be providing through this platform. And we're hoping that that's going to help researchers, explore multiple issues and then the different problems in different regions. And so just to give you an idea of how that might look like, as Meghna was saying in the introduction of the video, we start essentially with what we call the conceptual system diagram. And so in that conceptual system diagram, what you need to do is, sit down with your community, with those local administrators, right? And the global administrators, and say, okay, who are the main actors? Who are the people that we're going to try to model? What are the community leaders that are going to be providing input? What are the actions and what are the decisions that we're going to be considering? And then how are we going to track the impact of those decisions? And all of that has to map somehow to some sort of model. It can be quantitative or it can be qualitative, but it has to map to something that can help the algorithm find what the best solution is. right? And so in this case, I just presented a very simple scenario. This is model for SWAT, in which we're looking at, for example, a farmer with different water rights. They're trying to reduce their groundwater consumption because groundwater levels are being depleted, and they want to prevent, complete depletion of them. If we were to change the crops, part of the crop operations include the application of fertilizer, and that can include the amount and the type of fertilizer that you use, right? And so as you move through this optimization process, the algorithm is going to look at, okay, the fertilizer application for all of this region in different land units. Let's change the type, and then what is the impact of that, right? And then once we have that, we kind of agglomerate it, and we kind of summarize it in the metrics that we're keeping track, so that we can know whether we're moving in the right direction, given our goals and objectives. And so one thing that it's unique about this whole process is the amount of data needed to just create some of these models, right? And not only that, but then set up the optimization framework. And so just for the SWAT model, just to give you an idea of what this might look like, just to set up the SWAT model, you need, watershed boundaries, you need elevation data, you need streams, you need land use, and that includes not only land cover, but also cropland data. You need soil type, you need water rights, crop yields, you need so many different data sets just to set up a model that represents well what you're seeing in the region. And not only that, once you have that model, then all of these landscapes get divided into very small land units. They're called hydrologic response unit. And so they're very tiny patches of land that have a unique combination of soil, slope, and land. And so as you can start imagining, all of those little patches of land have different decisions associated with them. So you can have different crop choices, you can have different irrigation techniques, you can have different fertilizer applications, and so forth, right? And so once you start creating all of this, and you blow it out to, let's say, a region, for example, the one that we're using, which is the Umatilla region, it's in the northeast of Oregon, this becomes a humongous problem, right? You have all these tiny patches of land, all of them with different decisions, and all of them somehow need to come to an adaptation plan that makes sense, not only for the individual farmer that is managing that patch of land, but also for the regional goals. And so this is something that we're still working on. We're still trying to understand what is the best way of approaching this within this framework that we're proposing, but it wouldn't be possible to do some of this stuff if we didn't have the help from the cyber infrastructure. And not only that, right, what it's critical to understand is that without the cyber infrastructure, this wouldn't be possible for people that might not be familiar with the models and might want to explore different aspects, right? And so I think that's what it's very unique and appealing about this project, is that once you have this kind of framework / models packaged as different applications, you can have people come in and just follow, the instructions for, hey, this is the input data that it's needed to run this application. This is the format that you need to provide it. And once you provide that, then you start generating scenarios, right? Now you get the analytical part about it. You just have to provide the input data for it. Not only that, but we're also working on providing some of these applications as almost like pre-processing the data that you need to package and import into some of the analytical tools. And so that's really the appealing part about this, that the global administrators can look at this and say, I have no modeling or optimization experience, but I know that I want to explore this problem that is particular to this region. How can we do this? How can we start collaborating? And so the last part, super quickly, I know that I'm super over time, Suraj, I apologize. Dashboard was something that we have gone through multiple iterations. It has been a very tedious and complex process. All the thanks goes to the Science Gateway team, and particularly Aquila, that has been working extremely hard on this. But last year we had this evaluation of where we were with the dashboard itself, and we had a heuristic evaluation, then a usability testing, and all of that led to some new mock-ups that we're still working on some of them, but they improve the dashboard incrementally. And now we don't only have a project dashboard, which is what we started with. It was just a dashboard that was presenting the input data and then the results from the simulations to the users, to now having a full-on user dashboard that the user can have multiple projects, it can have multiple roles in different projects. Not only that, it can also look at how different plans for that particular project were evaluated, how other people are rating it. They can share projects between themselves. They can share projects with the local administrators. They can share projects with groups. They can provide feedback. And so all of this provides this really nice space for collaboration, and not only for collaboration, as I'm going to talk a little bit more in the future work, but for starting to use some of the AI capabilities to start learning how to just make sense of all of this feedback that we're going to start getting from, or hopefully we're going to start getting from, the community. So that's about what I have for you. I know I went a little bit over time, so Suresh, apologies, but I will pass it on back to you now.
Yeah, thank you, Sammy. Eroma, please start sharing your screen. So yeah, we'll thank Meghna and Sammy for this wonderful vision. It's been an exciting project for us to work on. So hope all of you enjoyed learning the vision here. So please have your questions coming on the chat. We'll try and leave time towards the end to answer them. Thank you. Eroma, please.
Hi, Suresh. Can you see my screen?
We saw it briefly and then it went back.
Okay, hold on.
Yeah.
How about now?
Yeah, we can now.
Thank you, Sammy, and thanks, Suresh. Hi, everyone. I'm Eroma, and I'm a member of the CERC Center here at Indiana University with Eric, and we are the ECSS consultants of the InterACTWEL project. So I took the liberty of borrowing this workflow from Meghna's presentation. So the stage 3 and 4, I feel that's where the gateway infrastructure and the Jetstream aspects come into the picture mostly. And I will talk a little bit about related to stage 4, and Eric would discuss about Jetstream. So the InterACTWEL gateway is hosted with the SciGap gateway platform with Apache Airavata as its middleware. And Sammy talked about these different layers of users, from global administrators to local administrators to actors, and also Meghna shared that they can be policymakers, decision makers, administrators, like that. So it's a non-traditional user base, and hence I feel it's a non-traditional gateway. And although they do their computations, their more focus is on visualizing and enabling visualizing for different users and evaluating and them being able to learn from that. So there are 4 aspects of the gateway I'm going to quickly share. And I want to quickly touch on security, extendability, data handling, and the sustainability. So security is one of the main focuses because of all the different levels of users we just get to know about, and all those data available for them. And because of these different levels of user, who has access to what matters, because it needs to be relevant to them, and some of the users being global administrators be able to control who has access to what. And because of that, we use the Apache Custos framework for all these security aspects and sharing aspects. And Custos, to name few, takes care of authentication, authorization, user management, and sharing aspects, having user groups and things such as those in place. And the next is, so the Meghna, Sammy, and the team, so the current InterACTWEL gateway, when we initially deployed, it's deployed with developed and with Django framework, which makes things easy to modify, extend, and integrate as we go on. And InterACTWEL project has this InterACTWEL dashboard, which is for users to visualize and evaluate their plans. So because of this, the PIs, the InterACTWEL team designs and reviews and develops very actively these interfaces. And the extendability of the Django framework makes it easy for them to keep integrating these new features and new developments into the gateway. So the next, so Sami spoke about computing, and once the computer data is available, it needs to go through the processing step and make them ready for visualizing. And the IRA, the data framework, uses the parser workflows to make these data available for visualizing and depositing in them to the MongoDB of the InterACTWEL dashboard. And the parsers are executed as Docker containers. And as the project progresses, the gateway evolves, it's easy for them to keep on adding new parsers and parser workflows to get their data ready for the visualizing. So this is an ECS project, and we need to sort of have ways that the gateway can sustain beyond ECSS consultation. And InterACTWEL group is one of the groups that I've seen. They have these frequent stakeholder meetings, and they get their feedback and they keep improving, which results active development and additions to the gateway user dashboards. So the gateway is set up in such a way they can seamlessly develop and integrate and continue their work with the gateway, even beyond ECSS consultation. So they are set up with the relevant or required development operations so they can go on working with the gateway. So those are, with the time and all, I think those are just few brief things I wanted to touch, and I'll let Eric go to talk about the Jetstream aspects now. Thank you.
Thanks, Eroma. So yeah, I will talk briefly about how we've set up a computational backend for this project on the Jetstream Cloud. If you don't know already, Jetstream is an OpenStack cloud hosted at Indiana University and at the Texas Advanced Computing Center, available through Exceed. And it gives us the ability to define a completely flexible piece of infrastructure for a project that has an allocation. So everything except for like the RF out the middleware is running on the Jetstream Cloud. So the gateway is on there, and we also were able to build a flexible compute backend for this project, using something that we call the virtual HPC toolkit, which allows for efficient usage of an allocation through an HPC-like interface, which is typically an easier way to get people moving from traditional scientific projects to the cloud. Next slide, please. And the way that this looks is typically this is sort of a cartoon of how the virtual machines are deployed in the Jetstream Cloud. This is also applicable to other OpenStack clouds. So we've deployed this on the Aristotle Cloud Federation, sort of primarily led by Cornell as well. There's a sort of a main head node virtual machine that it waits to accept jobs submitted through the gateway. So as part of the ECSS project, I set this up and worked with Sami to make sure all of their software was installed on here. And when jobs are actually submitted to the gateway, worker compute nodes are spun up on demand to handle that computation as needed. So they don't have a whole bunch of machines constantly waiting to run calculations with. These are elastically created and destroyed as needed, which has been a really useful framework for this and other projects. All of the building blocks are open source. I'll just leave this in the slides. We're using the OpenHPC toolkit for a lot of the sources of the cluster management software. But we can skip this largely. The deployment is also completely open source. So if you have access to a different OpenStack cloud, you can check it out at github.com/exceed/CRI_Jetstream_cluster. That link is actually missing the /exceed. So if you have questions about this and are in the 10 minutes I'm trying to leave for questions, please feel free to speak up. The more interesting, the part of this that was different from other virtual cluster projects, next slide, was really supporting SWAT. So this was sort of a non-trivial thing to set up. It's typically run on Windows machines and not in an HPC environment necessarily. So it took a lot of hands-on work with Sammy to get that even buildable in our HPC-like environment. But I think it really paid off in terms of how easy it is to run through the workflow now. My next plans for this is to actually bake it into a container so that we could potentially support other resources beyond Jetstream if that ever becomes necessary for, say, larger data models or something, because we are sort of limited on the size of the things that we can manage. So when this grows beyond the scope of what we currently have, I'd like to be ready for that. And I'll call it all done for now. Thanks for listening.
Yeah, thank you, Eroma and Eric. Sergio, we've been trying to a little bit rush for the exceed portions, but we'll be happy to take questions. But before that, Eroma, if you can stop sharing, and let me request Sammy to briefly take a minute or two to talk about your future work, and then let's let the floor open for Q&A.
Sure, I can do that super quickly in just 1 minute. Just as kind of like a concluding slide of lesson learned and future directions. I mean, what we're trying to create is this safe digital space for coordinating and collaborating. And so that implies that we're not only on a stored data, we need to provide analytical capabilities. And so how that will look like, it's very dependent on the project and the people involved in it. And so we want to maintain that long-term stakeholder engagement and community interactions. You know, we want to maintain that privacy and transparency in the decision making, and just allow for anyone that it's interested in either contributing to the development of new models or the exploration of different issues with the current models in the platform. And so that's really what we're shooting for. And then as far as future directions, we're still building community of practices. So we're still bringing different researchers and different community end users to start engaging with us within the framework and within the science gateways to start creating more long-lasting collaborations. And something that we're really starting to dig into a little bit more in details is the application of artificial intelligence into all the aspects of the science gateway, from just analyzing the actual user data that we have and all that feedback that we're receiving. We have a colleague of ours, it's a PI in the project as well, that it's looking at how do you trust the rating from different people based on, you know, the input from many people in the community, all the way to just using meta models, and how do you trust a meta model to provide the correct interpretation of what the region might look like based on what the model was telling you. And so there's a lot of avenues that we can explore for the use of artificial intelligence in this Science Gateway. But I will stop there because I know we're running short on time. And I just want to give a big thank you to everyone for giving us this opportunity, and obviously to the Science Gateway team, because they have been awesome. So with that, we will take your questions.
Well, thank you very much, Suresh and project team. I think this is a really impressive project. I think in some ways, it's indicative of, I think, the future of, as it were, high performance and data-centric computing. It's, as Sammy said, it's very extensible. It's actually practically useful for things that we all kind of care about or should care about. And so, yeah, I think it's sets the stage, and speaking for, I guess, the kind of supply side or the provider side of the community, I think all of our service providers, whatever we can do to help with this project going forward, we will do. So, you know, just let us know what you need, and we'll make it happen as a team. I guess even after the end of Exceed, we'll make it happen. So
that's great to hear. Awesome.
So let me check here. I don't see any questions in the chat. So does anybody just want to raise their hands and ask questions?
So I have this is Sudhakar. I have a couple of comments. So one is, we have deployed SWAT on Stampede, for example, and, Big Red 3 and so on and so forth. There is, so as, we have seen, there's a lot of model dependent data. Of course, that's for a different project. In one of the projects, there are about 250,000 files that the SWAT is trying to read. And I don't know how it is doing that in Windows, but when it comes to Linux, that's a big IO problem. So we are trying to tackle those IO type issues. So which we wrote a paper which didn't get accepted in PERG, but I think we have a good solution to load the data, organize the data differently and load that into shared memory and reuse that in case you need to reuse that data. Particularly that particular project required reusing this data for different scenarios, like different climate models and things like that. So if that is useful, I think that you should probably definitely use that. So that's please.
I appreciate you bringing that to our attention, and please, if you feel comfortable sharing the paper, we will be all ears. We're super interested because it's definitely something that it's still in the back of our minds. I think the model that we have right now, it's big, but it's manageable because we made some simplifying assumptions to make the model manageable. But if there's ways to keep the complexity of the model without compromising the computational costs and all that stuff, that will be awesome. So yes, if you can share that with us, that will be amazing.
Yeah. Okay. So I will definitely do that. I'm also in the part of CERC team, so I think we should talk internally here and get that going. The other comment is, so it looks like you have different people, different stakeholders here, and they need to have different interfaces, right? For example, a farmer who comes to plug in their maybe whatever field or something, they should be able to put kind of identify what that farm is, where it is in maybe Oregon or in that watershed or something. Yep. And provide some information like what crop they are growing, or what fertilizer plan they have, something like that, which is totally different from a person who is running a SWAT model. So these interfaces are totally different. So is these different interfaces for different stakeholders is complete at this point, or where is it now?
Yeah, that's a great question. And honestly, we have been building this thing in layers. And we started with the most basic one, which was just present the input data, present the relevant data to the problem of the case study region to the stakeholders, allow them to choose different actors, actions that they want to consider, and goals. Those goals could be individual or regional goals. And then enable them to then analyze and then look at what are the impacts of those decisions, right? We started there. Then we built the user dashboard that now allows all of these sharing, or you can have your own account organized with different projects and things like that. And so the next step, it's essentially what you're suggesting, which is now, how do we get local administrators to contribute in a meaningful way to the modeling endeavors, right? And so you're completely right. If you were looking at a patch of land and you were just asking a farmer, what is your fertilizer, what is your tilling usage and things like that, we should have that capability built somewhere in here. Right now, it's just a matter of talking with the stakeholders, and we have been doing, I think, Meghna, which is on the call, she just joined a little bit later. She had a meeting in August with all the stakeholders in our case study region, and she was presenting the SWAT modeling efforts, and they were giving her feedback. Oh, change these parameters, change that. So that's how we're managing that problem now. But ideally, in a future, it will be something a little bit more seamless, in which you can directly affect the parameters of the model as you're about to set it up to run. So you're completely right, and it would be great if you have some ideas on how to do that, off the bat.
Well, thank you very much, folks. I think we're kind of at the top of the hour here. You guys, I mean, the Jetstream folks, you may want to see, oh, you already answered the Chunhan's question about Kubernetes and all of that, which is kind of more of a Jetstream question. So thank you again, everyone, for a really fantastic presentation and discussion. And you will see, I guess, in a couple of days, the recording on the ECSS Symposium website, as well as the slides. So with that, let us adjourn until the next symposium. Thank you all very much.